Hello everyone, today we are looking at lesson 4 in unit 1, the language of IB mathematics, and that's all about scientific notation, or what we might call standard form. Your EQ, or your objective, is to write 497.547 correct to 2 sig figs in scientific notation, and we want to know why is this preferred to maybe non-standard form. So let's go right into it. The year is 3531. The world has fallen apart. No, just kidding, we're not going to do that again. Standard form is just a way to write very small or very large numbers. A number is written in standard form if it is in the form a times 10 to the k power, where 1 is less than or equal to a and is less than 10, and k is an element of integers. So that sounds like a lot to think about. We're not going to do this stop, collaborate, and listen today. We're just going to move right into some examples to try and illustrate this. Okay, so for example, a very large number would be this one. The number of internet users in June 2010 was 2 times 10 to the 9. Let's think about what that would be. When we're multiplying by 10 to the 9, your exponent is telling you how many zeros come after the digits that you had. So that is 2 billion, or 2 followed by 9 zeros. Okay, the Earth's mass is 5.97 times 10 to the 24 kilograms. I don't want to write out 24 zeros, right? That would be ridiculous. So we don't want to do that. Let's go ahead and think about keeping that in standard form then. The average mass of a human cell is about 10 to the 9 grams. Again, super duper small. I do not want to write 0.000000009 grams, okay? Or actually, that would just be a 1 there. Sorry, I don't want to have to write that out. That's too much, okay? So we want to think about all of these as being in standard form. It's much easier for us to make quick comparisons between very large, very small numbers and communicate very large or very small numbers. Now, we notice that every one of these is indeed in standard form because of this fact that this is between 1 and 10, right? 2 is going to be in between 1 and 10. And then we have times 10 to the k power, where k is indeed an integer. Okay, the same is true with 5.97. 5.97 is a number between 1 and 10. Notice it does not have to be an integer. It can be a decimal value. It can be a rational number. But then the exponent is indeed an integer. Same thing here, 10 to the 9. What's a? Well, a in this case is 1. Okay, 1 times 10 to the negative 9 is the same thing as 10 to the negative 9. And then you think, wait, k is negative. That's okay. K still belongs to the integer set. They do not have to be positive integers here when we are talking about standard form. So for each, let's state the value of a and k. 5.97 times 10 to the 9. Well, a is going to be that coefficient. 5.97 times 10 to the 9. K is the exponent, 9. Here, 10 to the negative 6, we say a is 1, because this is the same as saying 1 times 10 to the negative 6, and k is going to be negative 6. Now, we want to decide which of these numbers is written in standard form or not, and justify your decision. Look at the first one, 2.06 times 10 to the negative 5. The a is 2.06. Is that between 1 and 10? And we'd say, yes, it is. What about k? Is k an integer? Yes, negative 5 is an integer. So we would say that 1 is indeed less than 2.06, which is less than 10, so that's satisfied. And k is equal to negative 5, which is belonging to the integer set. And that's how we justify that, yes, this is in standard form. Okay? With the next one, 13 times 10 to the 1/3, we can see pretty clearly right off the bat, 13 is not going to be in between 1 and 10. So right away, it's wrong. We can also see that k does not belong to the integer set. 1/3 is not an element of z. So we would say, no, this is not in standard form. Next one, 0.12 times 10 to the 7. It looks pretty close to standard form, but when we look at this closely, 1 is not less than 0.12, even if it is less than 10. So this does not work out. This is not in standard form. Okay, even though we do have an integer exponent, we do not have the value a being in standard form. How do we write numbers in standard form? Well, the first suggestion is to write down a, all the significant figures of the number, and place them immediately after or to the right of the first significant figure. Then we want to count the number of spaces you moved that decimal. If you move the decimal to the left, then k is positive. If you move the decimal to the right, then it is negative. Let's go and take a look at an example. Flip over your page. We want to write these numbers in standard form, showing our working. So how we can do that is, let's go ahead and think of 257 million with the decimal point. Now, move your decimal. We need to move it to the first significant figure. First significant figure is going to be right here after the 2. We need to move the decimal then from the right to the left, counting how many spaces we are moving. We moved it 8 spaces. Okay? So we would say that's going to be 2.57 times 10 to the 8 power. That's it. It's that simple. Okay? The next one, here we're going to have to move it to the right, which means our k is going to be negative. Our first significant figure is 4. We count how many places that decimal had to move, and that was 1, 2, 3, 4. So we have 4.3. Since we moved it from left to right, it's times 10 to the negative 4. Here's a quick cognitive double check for yourself. Cognitive meaning you're just thinking about it, you're looking at it, you're not doing any extra work, you're just thinking. How can we make sure that these were right? Negative exponents will mean very small numbers, as in less than 1. Okay? Anytime we are going to be experiencing a number in standard form that has an exponent that's negative, it's going to be a number that's less than 1. Okay? When we have an exponent that's positive, it should mean that it's going to be greater than 1. So we should end up with a pretty large number. Okay? Now, writing these numbers in ascending order, let's go ahead and try and figure out what that means. Ascending means going from smallest to biggest. So look for, first off, which one is going to be the smallest number. That's going to be a little bit tricky because these are not all in standard form. This is why we want standard form, because we want to be able to have quick comparisons with all of these numbers. So let's first off double check and see which ones are in standard form. 2.3 times 10 to the 6th power. That one is in standard form because we have an a that's between 1 and 10, so that one's fine. I'll go ahead and rewrite it just for kicks. So 2.3 times 10 to the 6. 3.4 times 10 to the 5. That is also already in standard form. The next one, 0.21 times 10 to the 7, that is not in standard form. So here's what that means. To get it to standard form, we need to move the decimal 1 spot over to the right, which means it's like making the exponent 1 less, or it's making it more negative. It's making it smaller, okay? So this is going to then be equivalent to 2.1 times not 10 to the 7, but because it's like moving it, for every decimal we move it to the right, we're taking away 1 exponent, so that's going to be 10 to the 6. By the same idea, here we have our decimal 215 times 10 to the 4. Move the decimal over 2 to the left, which means we're making the number bigger. We're making the exponent then plus 2 more. So that's going to be 2.15 times 10 to the 6. And now we are going to be able to see pretty quickly which one is indeed going to be the smallest. It's going to be the one with the smallest exponent. So the first one that we have, 3.4 times 10 to the 5th, that's going to be the smallest one. Now we can start to see each one of these pretty clear which one is going to be the next smallest, because they all have the same exponent, 6, 6, and 6. Okay? The smallest of these then is just based off of the coefficient, 2.1, 2.15, or 2.3. 2.1 is the smallest one, and that was written as 0.21 times 10 to the 7th. Since I'm told to write those numbers, I'm going to keep it in that original form. The next one, 215 times 10 to the 4, or the 2.15 times 10 to the 6. That was our next smallest one, or our next biggest one, I should say. And then finally, we have 3.4 times 10. 2.3 times 10 to the 6. And that is in ascending order. If at any point you need to pause and rewind, please feel free to do so. So, what if we didn't have these in standard form? Write the number of internet users in 2010 as a number that was not in standard form. That was something we did. That was the number 2 times 10 to the 9. And we would say, you're moving the decimal over 9 spaces. That's how you can think about it. Take that 2 and move it over 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our new decimal place. So to think about it, you'd start with that number, put the decimal, and then start moving it over 1, 2, 3, 4, 5, 6, 7, 8, 9. And for every loop that you made, put a 0. And then get rid of the original decimal that you made. And that's it. Okay? Now, let's practice with our GDC and be able to see when it's appropriate to write these numbers in standard form and why it's going to be beneficial when we have to do these really obscure, gross-looking calculations. Let x equal negative 5 plus square root 121 over 7 minus 1 squared. Calculate the value of x and write down your full calculator display. Okay? So, we'll go ahead and punch that in. Negative 5 plus square root of 121. First off, I want to make my fraction bar, so control divide. The negative sign is not minus. Minus is not going to actually give you a negative sign. You want to press the negative button that's over here to the left of the enter sign. That's going to negate a number rather than the operation subtraction. So we have negative 5 plus the square root, so control x squared of 121. Oops, excuse me. 121. And in the denominator, we have the quantity. So open up your parentheses. Those are to the left of the 0. 7 minus 1. Close it and square it. Press enter. And we can see that that's going to be 0.166667. That might terminate right there, but I'm going to highlight it, press enter, and see that that is indeed going to continue on. So it is a repeating decimal. Okay? So that is going to be 0.166667. That was my full calculator display, and we can write a ... to indicate that that is going to continue going. Write down the answer, correct to 3 sig figs. Well, that's going to be pretty easy because the third significant figure is the second 6, and we know that needs to round up. So 0.167. Now, write our answer from part B in the form a times 10 to the k, where 1 is less than a is less than 10, and k belongs to z. So we're just writing it in standard form, which means we just want to take that decimal and move it over to our first significant figure, and that's going to be right here. Okay? We moved it over to the right, which means we need to make our exponent negative. That's going to be 1.67. We only moved it one spot, so it's times 10 to the negative 1, and that does it. Okay? Next example. Let x equal 2.4 times 10 to the 4 and y equals 5.10 times 10 to the 5. Let's find the value 3x plus y. Okay? So we can go ahead and see what our calculator display is going to look like, but I want to put it into, I want to write it out, and we're going to put this into the calculator. We're not going to try and do this by hand. That would be kind of obnoxious. So let's go ahead and punch this into our calculator. Start with a new fresh line, 3, open up the parentheses, 2.4 times 10 to the 4. To get to the exponent, press the caret button. It's all the way over to the left. Press 4. Be very careful. Make sure that you use your arrows to arrow your cursor out of the exponent level. And now, out of the parentheses, then plus, open up your parentheses again for that other substitution, 5.10 times 10, raise it up to the 5th power. And hit enter, and there we should see 582,000. I want to double check and make sure that that's not going to go on and on and on. It does indeed terminate. So that answer is 582,000. Write it to correct to two significant figures. The second significant figure is the 8, which means we want to look at the 2 for rounding. That's going to tell us to round down. And there we have 580,000. Don't forget about those trailing zeros. Lastly, we have write our answer in standard form, a times 10 to the k. So our decimal place is over here. We want to take it and move it over 1, 2, 3, 4, 5 spaces. We moved it 5 spaces to the left, which means we should have a positive exponent. Thus, we have 5.80 times 10 to the 5th. That's what it was. Now, the problem here is I wrote this to 3 significant figures, but what was this answer correct to? That was correct to 2 significant figures. So we should actually keep this to 2 significant figures as well. And if we are to keep this to 2 significant figures, that would just be 5.8 times 10 to the 5th power. And that will do it. And there it is. So you guys now have some practice that will include some calculator work and just some basic problem solving stuff, but it's reiterating the same things that you've been doing, except now you have to be able to write them in scientific notation. Good luck. If you have questions, I will be happy to answer them next class. Thanks very much for watching. I'll see you guys next time.